Okay guys, so we are starting the live session. Yes, we are live now. Yep, we are live. Hey guys, welcome back to Coders Arcade. This is Ashank David and welcome back to Coders Arcade. Here in this live stream session, I am going to talk about the data structures and algorithms for placement series. This is session number 37 guys. Welcome all, and I hope so that I'm audible. I hope so that the screen is also visible, and if there is some noise coming, I have a solution for it. Let me just try that solution. I'll just reduce the film. Okay, so now I guess so that you are able to hear me properly, and I'm the only one operating the camera today. So in between the camera can go off. I'll switch it on for just 2 seconds. It may happen like that, but bear with this guys. Well, I hope so that everyone is able to now hear me properly. Everyone is able to see the screen properly. I am also visible properly, and I am audible as well. Guys, before I start with this video, I would like to request you people to please like, share and subscribe to our channel Coders Arcade, and don't forget to press the bell icon so that you won't miss any future updates. Well, share this live stream as much as possible so that those people who are really in need of learning DSA, they are also able to learn DSA, and it is easily accessible. Apart from this, join our Telegram session guys. Join our Telegram group, Coders Arcade channel on Telegram, to follow all the updates related to data structures and algorithms and the batches that we are preparing for the new dates. I hope so that this is very much clear guys. Without any further ado, let's get right into the concept guys, and let us start today's class. So in today's class, we are gonna actually see DFS. As you have already seen in the thumbnail, we are going to talk about graphs. We are going to talk about graphs. We are talking about graphs. In yesterday's class, we have finished up our breadth first search concept. In today's class, we will finish up depth first search concept, and that is your DFS. That is your DFS. Let us start guys. So today we are going to talk about graphs DFS. DFS stands for depth first search. Depth first search, DFS. Here guys, if you remember the trees concept, I have explained you DFS trees concept very clearly in, I guess, session number 24-25. You can go ahead and watch that. So if you haven't watched those videos, I would highly recommend to go ahead and watch those videos and come to this video, because this is like DFS and BFS we are talking about. And already what is breadth first search and what is depth first search, we have already understood there. In trees concept, this concept is absolutely important, so it started from there. And now because we are doing graphs, we have to do the same exact thing but in terms of graph. Now I will be creating a graph today, and I will be doing DFS traversal onto it today. It is a very simple concept, it is very easy. Recursion is applied here, and it is not as tough as the yesterday's one, BFS. BFS stands for breadth first search, and if you haven't watched that yesterday's video, I would highly recommend to watch that video to understand what is breadth first search. BFS as already covered in the yesterday's class, as I have discussed earlier. Alright guys, now let us talk about DFS here. As I already told, DFS stands for depth first search, where we are trying to search something into the depths of, maybe it can be a branch or it can be a graph. If we are talking about trees, this is how your trees will look like. Now I am just creating a quick tree here so that I can explain you. In depth first search, we start from the root and we go into depths of the tree, understanding where we can go, like this. Okay. And there were many different ways of following this, doing this. The very popular ones were three, which were pre-order, we had in order, and then we had post order. Okay, we have understood this. But guys, in graphs, these concepts doesn't exist anymore. Because in trees we used to have the branches, but in graphs we don't have branches. We have a graphical structure, a web or mesh of nodes and edges. So in graphs, no pre, in or post. Okay, in graphs no pre, in or post DFS. Alright guys, we are talking about graphs. Let us take an example of this graph. For example, randomly just creating some graph. Let us properly create this one. These are the two nodes, and this node will be kept right here in middle. Let us say this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. We will apply DFS in this graph and we will see how things work around this. Alright guys, let us talk about this. I am going to move on to another space here so that we have a lot of space. I am going to build this graph properly and then I am going to explain you. So graph will be a little bit bigger in size so that we can understand it very much clearly. Okay guys. Alright, this is the graph here. 0, 1, 2, 3, 4 and this is 5. Very much clear. So now we need to apply DFS. We need to apply what? DFS. DFS stands for depth first search. Depth first search. Let us apply here DFS or a depth first search. Alright guys, my camera will go off, so I will just click on to the button once so that it doesn't get off. Alright guys, let's continue here. So now to apply DFS, just like how in BFS in yesterday's class, I have told you some requirements, right? Let's talk about those requirements. The requirements in yesterday's class was what all requirements we were doing. We wanted a visited array, we wanted a queue, we wanted an answer vector, we wanted the adjacency list. But in this case of DFS, we only want two things. Practically we will require answer vector also, but let's see. We can have an adjacency list, ADJ list, adjacency list. Then we can have the visited vector, and we can have the answer matrix. Okay guys, we can have answer vector, excuse me. Yeah, we can have answer vector here. Okay. So now let us do a DFS traversal here. Let us start by creating the adjacency list. We will note down all. How do we create the adjacency list? We will note down all the nodes. So 0, 1, 2, 3, 4 and then 5. Okay. Now 0 has what all neighbors? 4. Then 1 has what all neighbors? 4 and 5. 2 has what all neighbors? 3 and 4. 3 has what all neighbors? 2 and 5. 4 has what all neighbors? 0, 1 and 5. No, not 0, 1 and 5. It is 0, 1 and 2. Then 5 has 1, 3. This is our adjacency list. We have already understood about adjacency list before also. If you guys have not understood it, you can watch our previous graphs concept videos. There I have explained you the graph representation of adjacency list just 2 videos back it is. Okay. Then here we have our visited vector. Visited vector. We will note down 0, 1, 2, 3, 4, 5. And by default everything will be false. 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 Okay. Then we have our answer vector. Now we can, I am not using the answer vector, I am making this as optional here, but in the code we will be using the answer vector, guys. Okay guys, let us trace it out and understand how we are going to do the job of applying the DFS traversal. Okay. So let us start. I am gonna do it like this. Let us say I am gonna start from 0. I am gonna start from 0. Let us say 0 is the node which we are starting from where we are starting. So guys, this time if I want to apply DFS, DFS means depth first search. When you are standing at a particular node, you will be following only one path at a time. Unlike BFS, BFS was slashing through nodes. If you remember the last class, the BFS traversal was taking all the neighbors into consideration at once, and hence it was called as breadth first search. But in depth first search, rather than taking up all the neighbors, rather than taking up all the neighbors of the node, you are only going into depth. Depth means you are just going towards the next neighbor. Whoever comes first, you are going to that next neighbor, and from there you are going to its next neighbor. For example, if you started from 0, you can go towards 4. Now after 4, 4 can have neighbors as 1 and 2. Now it is up to you which side you want to go. Again, the different ways of doing this, writing the code will give you different answers like BFS, because here there is no fixed starting point. But in this case also the same thing applies here, that either now you can go on to 1 or you can go towards 2. Okay guys. So answer will be different, but they both will be same until and unless you stop following the process. Just if you follow the process of what I am gonna say here, the answer will be correct. Alright guys, let us understand. So here I started from 0. So we are going to keep on calling, we are going to create one function here called as DFS, and we will recursively call that function, changing the next value, and we will be doing the job. First understand the logic, later on I will tell you how recursion is applied here. In order to create the code, how to write the code, I will explain you very shortly. But as of for now, understand the logic. Okay. So you started initially from 0. So I said that we will make a call DFS of 0. You made a call, first call DFS of 0. You are standing here, you called DFS of 0. Okay. As soon as you are standing there, mark 0 as visited. That 0 is already visited. Then what you do is go to 0's adjacency list and see who is its neighbor. 0 says go to my neighbor number 4. So here directly we will jump towards 4. That means by the adjacency list we are getting to know that we have to go to this direction, and we stand here. As soon as you stand here, DFS of 0 called DFS of 4. Understood my point guys? DFS of 0 called DFS of 4, because DFS of 0's neighbor was 4. Understood my point? So we will jump to this and the same function will be called recursively with the new neighbor updated from its adjacency list like this. Once you are done this, you have marked 0 as visited, and now because you have jumped on to 4, it is better to mark 4 also visited. I hope so that this logic is very clear to all of you. What I am trying to explain here is doing the job using all the features that you have available with and following the process. Now DFS of 0 said go to my adjacency list and call DFS of 4. So we went one step here. Now once you are standing at 4, you marked 4 also as visited, and now you will check directly from here, you will jump to 4. Now because you are standing at 4, its adjacency list will tell whose neighbor is going to come next. 4 says push or call my neighbor 0. Now you see, we are coming from 0 towards 4, but 4 says my first neighbor is 0. So 4 says go back, but this is where we use the visited array to check if 0 is visited or not. Here you have already marked 0 as true. That means it is already visited. If a node is already visited, you will not visit it again and you will skip that node. I hope so that this is very much clear. It is absolutely clear to all of you guys. Understood? Because 0 is already visited, we don't have to visit it, and 4's request to visit 0 is already discarded. We are not going back to 0 because it is already visited, and while traversing we cannot visit the same node. This is the rule, guys. To cover all the nodes efficiently, we don't have to visit the node which is already visited once. I hope so that this is very much clear to all of you. Now 4 says okay, if you are not going to 0, then you should go to 1. So we say check 1. Is 1 visited? No, 1 is not visited. So very good, mark it as visited and call 1. So DFS of 1 got called. 1 got called, we jumped to 1. I hope so that this is very much clear. Now DFS of 1 is visited, so you, rather than moving towards 2, you moved right here into this place like this. You moved this way, not that way. I hope so now this is very much clear to all of you how DFS traversal is being done, how BFS traversal is being performed. I hope so that this is very much clear, absolutely clear to every single one of you guys. Now after you have reached this, directly jump to 1 because now you are standing at 1, right? Now next step what you need to do is check the 1's adjacency list. Now 1 says that go to my neighbor 4. Now 4 you will check, is 4 visited? Yes. Here you observe that 4 was already visited, and my camera went off, guys. Just turn it, it came back. Yes, we are back live. Okay. So here because 1 said go to 4, which is its next neighbor, but we are coming from 4. So you see here that 4 is already visited. That means this needs to be ignored. We are not visiting 4 here. Understood this, guys, everyone? I hope so that this is absolutely clear to all of you. Understood? Next, we are going to check what is next after 1. 1 said okay, you are not visiting 4. Go to 5. Visit 5. Visit 5. Is 5 visited? No, 5 is not visited. So now you are going to visit it. Start by marking it as true and call DFS of 5. DFS of 5. DFS of 5. So from here you went this side like this and you are visiting 5. 5 is now, make sure 5 is visited, and directly you go to 5's adjacency list. That means here you go. Now 5 says that I have my next neighbor as 1. So you check, is 1 visited? Yes, 1 is visited. So you will not go to 1. You will skip 1. And then you will check. 5 said okay, you are not visiting 1, at least go to 3. So now we will check, is 3 visited? 3 is not visited. So now you will visit the 3 and mark it as visited, and DFS of 5 called DFS of 3. DFS of 3 got called. DFS of 3 got called, guys. I hope so that this is very much clear. So now you went this side, and now you are standing at 3. Now when you are standing at 3, you directly jump to 3's adjacency list and check who is its next neighbor. 3 says my next neighbor is 2. Check if 2 visited. 2 was not visited. So mark it as true. Now we will visit it, and DFS of 3 called DFS of 2. I hope so that this is very much clear to all of you. So we went towards 2 and 2 was visited. In this side, in this direction, we visited 2, and hence you see 2 is now visited, right? When 2 is visited here, you jump to 2 and 2 says visit 3, but you see that 3 is already visited, so you skip this. Then you see 4. 4 is also visited, so you skip this. Understood my point? Now you see at the last you see here that 2's all the neighbors are covered already. So 2 says that I don't have any other neighbor, I am coming back to 3. 3 says that check 5. 5 was also, you came here. 3 said that 2 is already done, 2 is already visited, so we are not going to do this. 5 is left, which is already visited, so 3 says that I am coming back to 5. So 3 says I am coming back to 5, and 5 says I have 3. 3 is already visited, so this is also gone. 5 says I am coming back to 1. So 5 says I am going back to 1. 1 says 5 is left. 5 said I was already visited. Then 1 says I am coming back to 4. 4 says 2 is left, but 2 was already visited. So 4 says I don't have any other solution, I am going back. It went to 0, and 0 said 4. 4 is already visited now. 4 said I am also visited. So 4 said okay, return back and return the answer from here. This becomes your answer. Your answer is 0, 4, 1, 5, 3, 2. Your answer is, this is your answer. Answer is 0, 0, 4, 1, 4, 1, 5, 3, 2. 5, 3, 2. Check it out, guys. Check it out, guys. You started from 0, went towards 4. After that, you said go towards 1. From 1 you go towards 5, 0, 4, 1, 5, then 5 said go towards 3, and then 3 said go towards 2, and hence we are traveling in this direction. We visited all the nodes, and our answer finally came as 0, 4, 1, 5, 3, 2. I hope so that this is absolutely clear. This is the explanation of DFS. What you did is went to the nodes adjacency list, recursively called its next absolute next neighbor, and as soon as you called its absolute next neighbor, that neighbor said that go to my absolute next neighbor. When you went there, the next neighbor said go to my absolute neighbor, like that, and this cycle moves on. How do you do this? You will apply recursion. Whichever function you will write for DFS, there you will require to do recursion. This process can only be achieved using recursion. I hope so that this is absolutely clear to all of you. See how easy it was to do DFS traversal, depth first search traversal. This logic is very clear. I hope so that this is very much easy to understand. Now let us go towards our code and understand how the code is written, guys. So absolutely awesome. It is very easy. You see, we start from the main. We started by taking N and M, which is nodes and vertices and edges. There are nodes or edges, whatever you would like to say. We entered nodes and the edges, number of vertices and the edges. Then we created the adjacency list here only in the main. And with the help of, by taking all the edges one by one, we are using a for loop, taking the edges and we are pushing it into the adjacency list, creating an adjacency list representation. This we have already discussed in 2 videos back. So if you guys have not understood this, go back to our 34th video, there I have explained you how to do this. Alright guys, then we are calling this function called as DFS Traversal, which is written right here. In DFS Traversal, we are passing the starting node. Which node we are starting from? Here generally we are starting from 0. Then the whole adjacency list is passed. So the starting node, the adjacency list is passed here. Inside this function, I have created the Boolean type of visited vector, just like how we did in DFS Traversal. Then this is the traversal order or the answer. You guys already know this from the yesterday's class. Understood this? This is the answer vector. So here I said traversal order. Traversal order is the answer vector. Now I know that it is like very confusing. What I have done here is I have created another function though, but it is not necessary. It is like a helper function. And you guys already know, if you are watching my series from the beginning, you guys already know what is a helper function. I have created an helper function called as DFS Traversal util, okay, which is another function like this, where I have passed the starting index, the adjacency list, the visited node and the answer vector. Okay guys, just like how we did BFS, same way, same style, we are doing DFS. This function is going to be recursive. So you see, void DFS util, DFS traversal util, we are passing the starting node, we are passing the adjacency list, we are passing the visited vector and we are passing the traversal order, which is the answer in this case. Where do we start from? We started by, because it is 0, right? We passed the index 0 at the beginning. We will mark 0 as visited. So visited of node, visited of 0 equals to true. Because you are standing at 0, you marked it as true that it is already visited. You also printed 0 into the answer vector. So first 0 came already in the answer. Alright guys. And then you went to zeros for neighbor in adjacency list of 0, means you went to zeros adjacency list and there you checked if not of visited of neighbor, means in that zeros first element, the first neighbor, if it is not visited, then you will call that neighbor as the new call. You will again call the same function and will pass that neighbor as the new node and then adjacency list, visited and traversal order again. So this happened here. You went to 0, you saw 4. 4 is the absolute neighbor, right? So here what happened is, this is 4. If not of visited of 4, which is not visited of course. So go and call the same function with 4 here. Go and call the same function with 4 here. I hope so that this is very much clear to all of you. It is very easy to understand guys. Correct? Understood this? Go visit 4 and then do the same exact thing. So we are one level of recursion down here guys. You see, one level of recursion down we came to 4. Now 4 adjacency list we will go and its absolute neighbor is going to be get checked. So now 4 is here. Mark 4 as visited and print 4 in the answer vector. After that, go to 4's adjacency list and whichever is the first neighbor, check if it is visited or not. Who is 4's first neighbor? 0 is the 4's first neighbor is 0. You saw 0 is the first neighbor. So you will check if 0 is visited or not. And you saw that from this 0 was already visited. When 0 was already visited, you will not do this again. You will not do this again. For loop will again start and this neighbor will change it to the next neighbor. After 0, who is there? After 0 we have 1. We have 1. You see, after 0 we have 1 as the absolute neighbor. Again go back to the for loop and check if 1 is visited or not. 1 was not visited. So call the same function again with 1. Call the same function again, but this time with 1. I hope so you are getting my point, what I am trying to say. Okay. 1 and the adjacency list, visited array and the answer vector, that is fine. Now mark 1 as visited, then push 1 into the answer vector. So in answer vector what all things we had? 0, 4 and 1 right now. Understood? Now go to 1's adjacency list. Go to 1's adjacency list. go to 1's adjacency list. In 1's adjacency list, you saw 4. You saw 4. Is 4 visited? Yes, 4 is already visited. So this thing will not work. It will go back and we'll see what is next after 4. 5 we have. Is 5 visited? No, 5 was not visited. So call again after 1, you will call 5 as the new node and the same thing happens. So you see, after 1 you called, 5, correct? You called 5. I hope so that this is very much clear to all of you guys. Okay, now 5 is called. So we will go to 5's adjacency list and check who all are the neighbors. The absolute neighbor is 1. Now 1, we will check if it is visited or not. See the code. Okay. Now you called this with 5. So mark 5 as true, visited, push 5. So what all things are there? 0, 4, 1, 5 in the answer vector. Understood? And go towards 5's adjacency list and go to its first neighbor, absolute neighbor, which is gonna be 1. Check. 1. Check. If 1 is visited, 1 is visited. So don't do this. Go to its next absolute neighbor. Next absolute neighbor is 3. Is 3 visited? No, 3 was not visited. So now go and call the same function again, and this time 5 will call 3. 5 will call 3. As you can see, 5 is calling 3 here. Alright guys, 5 is calling 3 here. Now 3, mark 3 as visited, push 3 in the answer. So what all things are there in the answer? 0, 4, 1, 5, 3. Like this. Understood my point? And then go to 3's adjacency list and check who is its 3's absolute neighbor? 2. Is 2 visited? Is 2 visited? Yes, 2 is visited. So don't do this. Check next. Who is next? 5. Is 5 visited? Yes, 5 is visited. So in this 3, we were at 3. 5 was visited? No, 5 was not visited. So here you call that and then you go like that. So the same process again and again keeps on happening, guys, and you see that it will return you the answer vector. Ultimately, at the end of the iteration, you will get 0, 4, 1, 5, 3, 2. This is your answer, guys. We will run this code and check if it works or not. I will run this code and we will input this. We will input this whole graph in the input. So how many nodes do we have? We have 1, 2, 3, 4, 5, 6 nodes. How many edges do you have? 1, 2, 3, 4, 5, 6. 6 edges and 6 nodes. So I will say 6, 6 space 6. Okay. Now it will ask us what enter the edges. I have not written that in the code, but yeah, you can write that by yourself, I believe. Okay. 0 to 4 we have. So I said 0 to 4. Then 4 to 1 we have. So I said 4 to 1. 1 to 5 we have. 1 to 5. 5 to 3 we have. 5 to 3. 3 to 2 we have. 3 to 2 we have. 2 to 1 we have. 2 to 1 we have. And guys, is the answer correct? 041532. 041532. See here. 041532. Absolutely correct. I hope so that this is very much clear to all of you. We have understood and successfully finished our DFS Traversal. If you have any doubts, please do ask me, and we will start our doubt session now. Alright guys, today's concept is over, guys. I hope so that this is very much clear to all of you. This is your DFS Traversal. This is your DFS Traversal code. I will give this code, I'll pin this code in the comment section below and you guys enjoy. But I hope so that it is very much clear. If you have any doubts, please ask me in the comment section. I am seeing that and nobody is asking any doubts. So I believe that you have understood this really well. If it is clear, I'll be logging off, guys, and I will be seeing you again on Monday. Tomorrow is Sunday, so tomorrow there is no live session. Directly on Monday. Now that we have done DFS, BFS, Graph Traversal, graph representation, matrix, adjacency list, adjacency matrix, we have understood everything about graphs. We have covered a lot of things in graphs. So we'll do 1 or 2 graphs algorithms, and then we can finish up our DSA course. I hope so that this is very much clear to all of you. Today's session you have understood. If you have liked today's session, hit that like button. I can see that like button. Hit that like button. If you have any doubts, please do ask me in the comment section below. If you are not having any doubts, thank you so much for watching. Thank you so much for supporting till here, and I will see you directly on Monday. Before I leave, guys, I would like to request you people to like, share and subscribe, and don't forget to press the bell icon also, so that you won't miss any future updates. Also, join our Telegram channel. Telegram channel's link is in the description below. I will share the notes, the PDF of this Blackboard in the description below, so you can go ahead and access that. If you want to join our DSA course, you can contact us, and everything is given in the description below. Apart from that, follow us on Telegram, of course, and do share this live stream, guys, to many people as possible, so that whoever wants to learn DSA can learn it all for free. Well, guys, thank you so much for watching. There are no doubts here. I cannot see any doubts, so I'll be logging off for the day, and yeah, I will see you on Monday. I will again see you on Monday. Monday is going to be which date? Today is 5th, 6th, 7th. I'll directly see on 7th of October, and at 7th of October at 7 o'clock, guys. 7th of October, 7 o'clock, guys. Alright, guys. I hope so that this is very much clear to all of you. 7 o'clock Indian Standard Time. I will be back again with a new concept in graph, where I'll be telling you about how the things work. I'll be telling about how everything works onto this, and that's it. By the end of the next week, before Saturday, I hope so that we will be able to finish the concepts. Alright, guys. Thank you guys so much for watching. This is Ashank David. I'll be signing off now. Thank you for watching. Hit that like button, and don't forget to press the bell icon and hit that subscribe button also, so that you won't miss our future updates. Don't forget to follow our Telegram channel as well. That is very, very much important, guys. So make sure that you do that in the first place. Alright, guys. Thank you so much for watching. I'll be going off. Take care. Happy weekend. Take care. And keep supporting us, guys. Thank you guys so much again for watching us. Take care. Stay healthy. I'll see you on Monday. Bye bye. This is Ashank David signing off.